Hi everyone, my name is Jocelyn, so I major in computer science.
Hi, it's AJ again, and yeah, I'm excited to jump into our topic for this video, an introduction to algorithms. And we're relating this to coding, but it's kind of a larger topic than just coding.
Yeah, definitely.
Okay, well, go ahead.
Sure. So today we're going to learn about algorithm. I believe most of people have already heard about algorithm before. So give just a brief introduction. So an algorithm is a procedure or formula for solving a problem based on conducting a sequence of specified actions. So remember, like for algorithm, it has to be, first of all, it has to be a sequence, and then it has to be very specific. For example, if you would like to determine how to do your dishwashing, so you can, there are a variety of ways you could do, but you have to decide what to wash first. You can wash your plates or you can wash your cups first. If you're going to use warm water or use cold water, if you're going to make your water running all the time or you're going to stop at this time. So it has to be very specified.
Yeah, so I'm going to use this moment to get everyone to wash dishes how I do.
Yeah.
So I fill up one side of the sink with soapy water, hot, and it's empty.
Yep.
And I fill up and I clean the other side of the sink. And so what I do is I stack all my dishes. I do all my silverware first, and I don't wash it right away. I just let it sit, because silverware, let it in the hot water, get sterilized and stuff. And then I do my cups first, and I put them all in the soapy water, wash them, put them in the clean, empty tub, and then turn on the water again with hot water to rinse them and hang them up.
Yeah.
And then I just keep going like that.
So this is kind of an algorithm in real life then.
Cool. So I can program a robot to do my dishes for me.
Yeah, in your own way.
Yes.
Yeah.
Okay.
So this is a perfect example for algorithm. So we're going to, because this is a programming class, so we have to teach you how to find the algorithm for programming specifically. So when you think about how to write algorithm for program, there are couple questions you have to think about. For example, the first of all, does this program require any input? And what are the output for this program? For example, if you're going to make a classification on the self-driving car, if it's a plastic bag or it's the kids, so
so that the car won't hit a kid, but we'll just drive right through the plastic bag.
Yes. So if you're going to write the algorithm for that, obviously the input here would be the image of the car at this moment, and the output for the program would be whether this is a kid or this is a plastic bag.
And then whether I should keep going or hit the brakes.
Yes, this is also the output of the program.
Okay.
So this is the first thing you have to think about. The second one is if I would like to do the procedure in my brain, what are the steps?
Interesting. Yeah, explain that one.
Okay, so let's back to the classification on whether it's a kid's or it's a plastic bag in a self-driving car. So if you see an image, as a car could see, just in front of you, you see a object over there. So how do you, in your brain, how do you realize this is for example, suppose it's a kid's. How do you realize it's a kid's?
Right, I'll see the kid's face.
Yes.
I'll see their body, how they're moving.
Yes.
I remember hearing about this. This is a difficult problem that we're talking about right now, but tackling it is hard because we have a better depth perception than a video camera.
Yes.
But if it's a bag, it's you can tell it's lightweight, just the way it's moving or blowing in the wind or suddenly floating in the air. A kid's not going to do that. Yeah,
so this is a very good example about how to classify. So if you're going to do this in your brain, this is the process, so you have to apply exactly the same steps into a program when you write it. So the third one is more programming related. For example, how many variables do I need? We all learned about variables in previous classes. So
yeah, how do you determine how many you're going to need for something?
Yeah, so that exactly depends on your steps.
Okay.
Right? So, for example, in our classification program, you obviously need a variable to store your image, right?
Okay.
So this is one of the variables you need. And you might also need a variable to store your output. Okay. So there will be two variables at least. and you might need more.
And for each output, because we were talking about whether to keep driving or hit the brakes,
Yes.
whether it's a kid or something not to hit,
Yep.
or something to hit, because it won't make a difference like a bag. So each thing would be a variable.
Yeah, you need a variable for each of the things. So
Okay. Oh, things that might have one outcome or a different outcome,
Yes.
and also storing data.
yes, you have to store data at some point that depend on your steps.
Okay.
But this is another thing you have to keep in mind, especially if you write your program.
For the dishes example, that's easier. So how many variables are there? Oh, like temperature of the water.
Yes.
How much soap?
Do you need?
Yeah, how much soap do you need?
And how long do you want to keep the water keep running?
Yeah. Oh, and how do you determine whether the dish is clean or if there's like a
Spot on.
stubborn stain?
Yeah.
Okay, gotcha.
So, and you might also want to think about what data structure you need for each variable. That will be a more complicated thing.
Yeah, that seems
I think we'll learn about integer, strings, and list in Python. So this is like the data structure you need for them.
Oh, the type of data.
Yes.
So is this a number, like in temperature, it would be a number.
Mm-hmm.
But if it, like an integer, but if it's a photo or an image,
Yes.
then it's a string.
Yes, it's
Referring to a
either
file.
a string or a list or something.
Oh, okay.
Yes.
Sure.
So you have to think about that. And finally, you have to think about your programming more detailed. For example, if you need to use any conditional statement, or do you need to use any loops? So we both learn about a conditional statement, which is if-else statement, and loops, which is like for and while, those stuff. So this is like when you write, trying to find your algorithm, you have to keep in mind, like if this is the step that I need to have an if statement there.
So I thought of a variable for the dish example. If I'm washing plates,
Yes.
the variable is how many plates are left
Yeah.
that are dirty.
Mm-hmm.
And then the data structure would be integer.
Yes.
And so while there are more than zero
Dishes.
dirty dishes,
You have to keep washing.
you have to keep washing,
Yes.
and that's a loop. And
Yes.
And then when there are zero dirty dishes, then
You
I can
turn the water off.
yeah,
for
pull
example.
out the drain, let the water go out, all
Yes,
that.
that's like the perfect example. So
I
by
like
going
it.
through all these steps, we can find a dishwashing example, and you can using what you're thinking over there to turn it into a program.
Okay.
So we learned about how the question you have to think about. So this is the time we have to go through some very simple example to answer this question. I know we already answered some of them.
Yeah.
Just
We need more practice.
Yes. So how do you write the algorithm? Because we haven't reached to how to write a program yet. So you can do it in essays, bullet point, the pseudocode. We're going to have a video about how to write the pseudocode, but we're going to show you how to write the algorithm in some of these forms.
So we can do essays, we can do bullet points, that's fine.
Yeah, you can do any of them.
It's so like whatever helps you to keep track of all the steps.
Yes,
So you
that's
record
correct.
it. Okay.
Yep. So let's go through some examples.
Yes.
For example, when to hanging out with the friends. You want to write a chat program to ask your friend to hang out with you.
Okay.
So, like first question, what is the input and output?
Input? That's hard. It seems easy, but it's hard. Help me out. What would an input
if you
be
think
for
about
you?
it, you want to check with your friend. You want to tell your friend to hang out. So you have to, the input would be when to hang out, where to hang out, and what do you do when you're hanging out.
Okay, so input could be kind of questions that you have.
Yes.
So-
or the answers to that question.
Yeah, so my first input might be hello,
Yes.
and then I'm hoping for an input is hello,
Yeah.
and then like an input might be, are you free Saturday afternoon?
Yeah. Something
And
like
then
that.
it'd be like, it depends. And I'd be like, to go see a movie? And it's like, oh, no, I don't like movies.
So these are kind of input to this program, right?
Okay.
So what are the output?
Is the output just whether we're going to hang out or not?
Yeah.
Oh,
So
okay.
whether this is like very simple yes or no output, whether you want to,
Or-
your friend agreed to hang out with you or
Yeah.
not.
Yeah, well, for me, either we're hanging out or we're not friends
Yes.
anymore.
Yeah, exactly. So how about the steps? Just like AJ already mentioned, you can ask a couple questions. So first of all, the program want to take user's input, and you send that input to your friends. This is the second step. And the third step is that you get the response from your friends. And the fourth step is that depend on their answer to decide whether to hang out or not.
And then if it's a really cool app for a chat program, once it can see that there's a date and a time and a place, it might suggest, can I add that to your calendar?
Yeah, that'll be one more step to do.
Yeah, or like, can I pull up Google Maps to put it there?
They're all very good ideas.
I've noticed there's a really cool thing with my iPhone. Sometimes when I look at the map, it shows me an appointment date and time on the map of where I'm going to be. Yeah, it's really cool.
Yeah, so this is like something you can add on to this program. And what variables do you need?
So dates, times.
Yes.
String text of the talking back and forth.
Yes, exactly.
Sometimes they check whether you have the program active. So like, has your friend seen the message?
Yeah.
Like in WhatsApp.
You do have that function.
It shows little checks of who's seen it and stuff
like
that.
So these are the variables.
Okay.
So do you need any conditions or do you need any loops?
Well, this is a good question. If we let's say we're talking about the type of app that or chat program that would suggest add it to your calendar, would that be a consistent loop that it's always checking, or is that more of an if? Like if Friday appears, add an option to suggest a calendar. Which one would it be?
I think that's actually depend on whether you want the program to always keep running or not.
Okay.
If you want the program just run one time, you don't need a loop for that. But you want it to continue running, you obviously need a loop for that.
Okay, so maybe I'm chatting with my friend and they're like, let's see Lord of the Rings Part 1 on Thursday, let's see Lord of the Rings Part 2 on Saturday, and let's see Lord of the Rings Part 3 on Sunday.
Yes.
And then you would loop through to all the calendar invites.
Yes.
Okay, cool.
Okay, so we have a pretty good idea about how to write an algorithm for this example. This is just a very brief example that I wrote. Okay. If I'm going to write a program, the first step is I ask I, which is I, to enter when to meet, where to meet, and what to do to the program.
Okay.
And after the second step is like send the information to your friend.
Oh.
And the third step, ask your friend to enter accept or reject the event. And fourth step, do a conditional check. If your friend enter accept, tell them hooray. Or if your friend enter reject, send them a sad face.
Or a mean face.
Yeah.
That's excellent. That's a lot faster than how long it takes me to talk about something like that I want to do with a friend.
Yes.
That's a great algorithm.
Yeah,
it's so fast.
So like look, I do highlight like when to meet, where to meet, what to do, and accept or reject.
Oh my gosh, those are all variables.
Yeah, which are all variables. And I actually have make this a
conditional?
Yes. So this is like a highlight for the syntax for if.
Oh, it's italicized.
Yes. So which means you have to apply to a conditional statement when you're trying to convert this algorithm to a program.
Gotcha. And like tell them that's just the print command.
Yeah, that's just the print.
Awesome.
Yes.
Makes sense.
This is like one of the simple examples. And let's go to see the second one.
Okay.
Decide if you want to get a car. You want to design an algorithm, decide if you could get a car. Your parents asked you to meet the following criteria in order to get a car.
Okay.
So
I went up to my parents and I'm like, I want a car.
Yeah.
And then they tell me the following.
Yes. For example, grade no lower than a B.
Okay.
At least 2 A's in the semester.
Okay.
Pay for your own gas and get to home by 11.
And okay, so that means they're gonna pay for the car and the insurance.
Yes. So if you think about it, what are the input and output in this case?
The inputs are your grades. More of your grades.
Yes.
So they really care about my grades in school.
Yeah.
Yes, we do. The money for gas and the agreement. The gas itself, I guess. And the stipulation, the curfew is the input, like when to be home.
Yes.
Okay.
That's correct. So what are the outputs?
The output is the car. No?
It's decide if you program
it's a yes or a no.
Yeah, it's a yes or no output.
Okay.
Yes. So, what are the steps then?
Do well in school. Get money.
Yes.
So maybe get a job, like apply for a job, get the job, And then as you get more money, you can pay for more gas.
Yes.
And make sure you have a working clock.
Yeah, that's correct. So do you need any conditional statement?
Oh, yeah. So we have to check through all the grades that were inputted.
Yes, exactly. Yes.
Oh, a loop through the grades to say, is this a
yes,
B
you
or
actually
an
might
A?
need a loop for that.
Yeah. And then make sure all of them are higher than a B.
Mm-hmm.
So you'd have to first, like, the data structure.
Yes.
Maybe convert all the letter grades to number grades. Like a B is a 3.0.
Yeah, you might need to
And
do
so it
that.
has to be 3 or higher for each grade.
Yes.
And then loop through again to find at least 2 A's.
Mm-hmm.
And then the gas part is kind of...
Yeah, I
It's
think
like
just
later.
like a yes or no question.
Yeah.
Uh-huh.
And then if ever I'm home past 11, I lose the car.
Yes, that's exactly right.
Or if the car runs out of gas.
Yes. So like for AJ just said he already have a perfect algorithm for what's going on with the program.
Oh,
so
thank you.
yes, so let's just see an example that I wrote. Note that I write the algorithm in terms of bullet point. You can do it otherwise too.
Yeah.
So the input will be yes or no from the user.
Mm-hmm.
You might get other input too. This is just an example. Output, if you could get a card, this is also yes or no. So if I would write a program, I'm writing this way. I ask user to enter if they get a grade lower than B. So that would be just yes or no. If the user said no, then we can proceed to the next question. And if your user said yes, output just no.
Okay.
And then
You lost the car.
you
gotta see.
lost the card. Yes. Second, ask user how many A's they got. If they say the number greater or equals than 2, no, this is like a condition that we learn in the if statement.
Sure.
And if they get more than 2 A's, they proceed. And otherwise, output no. And
Awesome.
ask user if they could pay for your own gas. Well, they have to be honest in this case, though. They say no, then this is actually wrong.
Oh, yeah, it should say yes.
Yeah.
That's okay.
Okay. And ask user if when they
I
get
can fix it quick while you're talking.
Yeah, sure. And ask user when they get home. If the user get home later than 11 p.m., we should output no. Okay, this is wrong too.
Okay, so ask user when they get home. If the user
Earlier.
later than 11.
That should be earlier.
Earlier than 11.
Yes.
Yeah, okay, gotcha. Perfect. And I mean, that's a big thing. Always be willing to fix your algorithm as you find mistakes,
Yes.
right?
So if you pass all these questions, then you output yes. So this is like a bullet point style for this program.
Yeah, I like it.
Mm-hmm.
So what do we got after this? Or is that the last one?
Yeah, that's the last one.
Oh, excellent. So, like in my example, we
Mm-hmm.
had talked about, just to kind of wrap up this video, we had talked about for getting a car, I need money somehow.
Yes.
And so some ways in which we can talk about making a more efficient algorithm
Yes.
is look at the algorithm you made and
Mhm.
it works, and then see where can I take some shortcuts here, right?
Yes.
So if we go back to decide if you want to get a car, if I'm start my own business
Mhm.
and make enough money to buy my own car and pay for my insurance,
Mhm.
then I don't need to get all the things that my parents said.
Yes, exactly.
Except I still got to get home by 11 because there could be other consequences. Cool. Well, thank you again for your help today in us understanding algorithms.
Yeah, thank you.
I learned so much. Bye.
Bye.